Right. Good evening, everyone. So today we are going to discuss about forces. We are going to learn about forces and how forces are going to be explained through the Newton's three laws about motion. First of all, we have discussed about how particles move uh, with respect to the displacement, acceleration, deceleration, velocities based on kinematics explanations. And this is a situation we are going to learn the same thing about motion, but in a different way. It's based on the forces. So uh, this is the study of these forces. Let's call it dynamics. So we are going to learn about how forces are going to act on a motion. So forces and motion. Right. First, we have to understand like what is a force is. Right? Force is in simple word we call a force is a push or a pull. But actually force has a much better explanation according to Newton's second law. But in a simple form, force is a push or a pull. And what actually forces have, like every force has three features. A forces has a magnitude. A force can have a magnitude. Right? Magnitude means the forces have a value, a size for the force. And forces can have a direction. And also, a force can have a line of action. Line of action. Line of action means forces can have a specific, or maybe you can also call it an imaginary line, where the forces have uh, expected to be act due, through that line. So we call it the line of action. And what forces can do? Forces can do things like this. When you apply a force or a stationary object, you can let the object to move because why? You're providing an unbalanced force. We call them unbalanced forces. So by creating an unbalanced force, we can let the object travel. So force can travel an object. So force can start a motion. And also force can stop the motion. So like for example, uh, a vehicle apply brakes. So a force can stop a motion. And another thing is a force can change the velocity, which means a force is responsible for the acceleration of a motion. So actually the acceleration depends on the force more than velocity. So when you change the force we apply on a vehicle, we change the acceleration provided to the vehicle. Either we increase acceleration or we decrease acceleration. By doing that, we can change the velocity. So force can change velocity. Not only that, the forces can also changes the direction. For example, like when we're moving in a road, like a vehicle moves in a road, if the vehicle meets a bend, a circular bend, it has to travel in a circular path so that the force has to kind of switch into a centripetal force so that the force can provide a circular path for the vehicle to travel. So in that case, we'll let the vehicle to change the direction. So in that case, the force can change direction of motion. And one more thing I will include to this list, that is a force can change the shape of a body. For example, you take a small sponge and squeeze with your hand, so which changes the shape. To do that, we apply a force. So we can change the shape right? So these are the forces can do. They can start a motion, they can stop motion, they can change the velocity, they can change the direction of motion, they can also change the shape of a body, right? Now, some systems requires more than one force. They may be applied in the same direction, they can apply it in the opposite direction, they can apply it in perpendicular direction, or else they can apply in any other direction other than 90-degree angle between them. So that the forces can be more than one in a system. When there are many forces within a system, we can find a resultant force for them. Resultant force. Resultant force, we actually call it many different names. Sometimes we can call a net force. Net force is also a similar word for resultant force. Sometimes we also call external force. External force. Sometimes we also call an unbalanced force. All these names refer to a one force, which is you call the resultant force. So the resultant force is usually defined using vector additions. If you want to calculate the resultant force, you have to consider their directions because force is a vector. So when we're finding this, we usually follow a vector additions, or else we call vector sum, right? Because the force is a vector, which means it has a direction. There are different types of forces in systems. The forces can be actually in many forms. Normally, in a stretched a spring or a rope or string has tension forces. A spring can be compressed, so we provide compressive forces. So we call them types of forces. Types of forces, there are many types. We can have a tension force. Tension is normally comes with a stretching of materials. And there are compressive forces. Compressive force means normally comes with compression of a spring. Compressive force. There are gravitational forces like weight, gravitational forces. And also there can be contact forces. And we also know there's another force, very commonly we use the friction forces or resistive forces. So these are different types of forces. Other than that, you also learn about electrostatic attractions, repulsions, that is also a force. Magnetic attractions, magnetic repulsions, that is also types of forces. And a friction is a type of force normally act between two moving objects. So friction is called an oppositive force. Oppositive force for the motion act between two surfaces which are moving relative to one another. one another. So that's what you call a friction force. Now, friction forces are very commonly be used in our calculations. When you do a lot of F equals ma calculation, we used to have these frictional forces with them. So this is the idea or else the overall view of what is a force means. Now let's go to another page and discuss what are the Newton laws and how they are going to be applied for this force. Right. Now, Newton laws, we call them actually Newton's laws of motion. We have studied about three laws under Newton's laws of motion. The first law is about balance of forces. Balance of forces. Which means here we discuss about what happens if a system has multiple forces and they are balanced. When forces are balanced, there are only two things can happen. That is, either object at rest, which means it's not moving, or object maintains a uniform velocity. Object maintains a uniform velocity. Now, these are two things that can happen when the forces are balanced. When the forces are balanced in a system, we call another name. We call them the system is in equilibrium. Equilibrium of forces. Right. Now, the other thing is now when it comes to the first law is always explain about what are the things we need for a system to be balanced under balance of forces. If the system is balanced, then the system does not have a resultant force. So basically the resultant force will be zero, becomes zero. That's very important. The resultant force is zero in the sense even the acceleration is zero. So under Newton's first law, we do not discuss about accelerating objects. We discuss about uniform velocity objects or objects which are at stationary conditions. So this is the first law. In the second law, we discuss about unbalanced forces. Second law is about unbalanced forces. Right. Whenever we have an unbalanced force in a system, it leads to have a resultant force. Like I said in the earlier page, unbalanced force is a resultant force. Now, if there is an unbalanced force, this is going to have a definitely an acceleration or a deceleration, which means the object now starting to change the velocity all the time. So this condition, we cannot have a uniform velocity or uniform motion. So it has to be an unbalanced force for accelerating condition according to the Newton's law, second law. Whenever there is an unbalanced force, there's another important thing is going to happen that is going to change the momentum change in the momentum, right? Because why? If there is an acceleration, there is a change in velocity. And if the velocity changes, they're going to have a change in momentum. And if there is an unbalanced force, and that unbalanced force is equal to the product of mass into acceleration, which is you call F equals ma, very popular equation for calculation, F equals ma. So in this case, this unbalanced force is what you call the F, and m is considered as the mass of the body. Now, according to this equation, force is directly proportional to the acceleration, which means acceleration always exists with a resultant force. So without a resultant force, we cannot have an acceleration. So it's directly proportional. If you increase the resultant force, it increases the acceleration. If you decrease the resultant force, it decreases the acceleration. And another thing is acceleration is inversely proportional to the mass. Higher the mass, lower the acceleration. Now, this is also expanding into another law, which is we call Newton's third law. So third law represents about action and reaction forces. So the third law states that every force, or in another word, every action has equal but opposite reaction force. Reaction or reaction force. There's a very important point that you need to learn under Newton's third law. Every action and reaction, they are equal in magnitude. Just because they are equal in magnitude and opposite direction, not all the forces are action and reaction. In order to be action and reaction, there are very important conditions for that. That both action and reaction, or both action and reaction, need to be act on two different bodies, which means when you take a bird sit on a tree branch, and when the bird want to fly from that, so what the bird does, it push the branch as an action, so that the branch push the bird with a reaction. You can see the action act on the branch, the reaction act on the bird. So action, reaction always act on two different bodies, like the bird and the branch. And action and reaction need to be same type of forces. Same type of forces. For example, action is a tension, reaction is also tension. But action is a tension, reaction is a gravitational force. That cannot be. So in order to be action and reaction, it has to be same type of forces, right? Now, that is about the conceptual idea of the Newton's first, second, and third laws. So when you try to remember them based on the conceptual idea of the law, that is easy to understand and also apply in calculations. Right. So this is all about the Newton's third law. Right. These two pages, I was trying to explain you about the basics idea about forces and how the forces were applied in the Newton's third law applications.